Today's lesson is looking at absolute value inequalities. These are inequalities that contain an absolute value expression. If you remember from absolute value equations, we talked about the absolute value of x being equal to 3, and we said, okay, so the inside this absolute value bar, you could either have 3, because the absolute value of 3 is 3, or you could have -3. So there were always two cases for these problems. Same concept goes with absolute value inequalities. You still have two cases. We have conjunctions and we have disjunctions. So any absolute value inequality that is less than a negative number is no solution, because if you had 8x plus 9, and you said that that is going to be less than 0, you can't produce anything that's going to be less than 0. Okay, so looking at number 1, we have the absolute value of x is less than or equal to 3. There's going to be two situations for this, because if you think about absolute value, you think about it being a number's distance from 0 on the number line. So if you're looking at this one, okay, we can see, so you have a number line, you have 0, you have the number 3. Okay, so x is anything less than or equal to 3. So you can choose all these numbers in here. So less than or equal to 3 is going to be any of these. So if I chose the number 6, that's not less than or equal to 3, so therefore 6 isn't part. But if I chose the number 0, 0 is less than or equal to 3. And likewise, if I look at -3, because -3 can be x's value because it has to be that same distance from 0. So -3, the absolute value of -3 is 3, therefore 3 is less than or equal to 3. But if I chose a number like -4, and I said, okay, -4, is -4, the absolute value of -4 is 4, is that less than or equal to 0, or to 3, excuse me? No, it is not. So that's not part of your solution set. So all the numbers down here are not part of the solution set. So the top number that it can be is the number 3. The bottom number that it can be is the number -3. So in this conjunction, it's all the numbers in between that create a solution to this absolute value inequality. So when we look at these, just like when we had equations, the absolute value of x can be less than or equal to 3, x -3. The tricky part here is that we have to flip our inequality symbol, because x can be anything less than or equal to 3, but it can only be anything greater than or equal to -3 to create the solution set for this. So the key piece when you're solving your absolute value inequalities is that you have to remember to take the inequality, and there's always two cases. So there's always the c plus 5 is less than 2. And then there's also at the other end of your number line, on the other side of 0, you have c plus 5, and you have -2, but it's not going to be less than this time. It's going to be greater than, okay, to talk about the other set of values that c can be. So -5 on both sides here, so c has to be less than -3, or c has to be greater than -7, excuse me, and these are all conjunctions because it starts as less than. So when you go and graph that, you'll see it's the conjunction between -7 and -3. So for this next one, n minus 6 is less than or equal to 4, and n minus 6 is greater than or equal to -4. So to figure this out, all you do is you create it just like we did with the equations, where you just drop your inequality symbols, because this value in here has to be less than or equal to 4. But the value in here for the second situation has to be greater than or equal to -4. So add 6, add 6. So n can be greater than or equal to 10, and add 6, add 6. N is greater than, or excuse me, less than or equal to 10, greater than or equal to, what did I do? Add 6. 2. Okay. The next one I want to look at is number 5. In number 5, a lot of students would jump to the no solution answer because it is less than a negative number. However, just like with our equations, we had to simplify the side first. we had to simplify as much as we possibly could first. So we added 5 to both sides for this one. So it's actually x, the absolute value of x plus 6 is less than 3. That is a 6. Does not look like a 6. The absolute value of x plus 6 is less than 3. So then you're going to go and do your two possibilities. So x plus 6 less than 3, x plus 6 is greater than negative 3. And then you're going to solve, and you'll get x is less than negative 3, and x is greater than negative 9. So it's the conjunction of those two. So likewise with number 6, we're going to divide by, you can do it two different ways. You can either distribute the negative 3, or I like to just divide by negative 3 on both sides. So that'll cancel, not the x though. The absolute value of x minus 2 is still there. You're dividing by a negative value, therefore you're going to flip your symbol. Greater than or equal to negative 3. So your two situations, x minus 2 is greater than or equal to negative 3. X minus 2 is less than or equal to 3. So x is greater than or equal to negative 1, and x is less than or equal to 5. So those are your conjunction ones. The next thing we have are disjunctions. Disjunctions are the same concepts as the conjunctions, except for the fact that it's going to create that or statement because it's starting as the absolute value of ax plus b is greater than c. So these create those that separation of your two values. So if you have x is greater than 4, that means x's value can be anything greater than 4. Is one possibility. X can be greater than 4, or x can be less than negative 4. Okay, so those are your two cases. It's either greater than 4 or less than negative 4. So again, you can see that if I do graph this, I have 0, so 4, negative 4. Greater than 4 is everything here and to the right. Less than negative 4 is here and to the left. So choose the numbers. This really demonstrates why you have to flip it. So if I choose a number that's greater than 4, I'm going to choose the number 5, and I plug 5 in. Yeah, 5, absolute value of 5 is 5, and that's greater than 4. I also shaded over negative 5, so if I plug negative 5 in there, the absolute value of negative 5 is 5, and again, it's greater than 4. So that's why when we are graphing these and when we're figuring out the two different cases, we have to flip this inequality symbol when we talk about the negative aspect of it. So all these other ones are identical to this, to our conjunction problems. We're going to look at them and we're going to say, okay, so the absolute value of x plus 7, so it has two cases. X plus 7 is greater than 3, or x plus 7 is less than negative 3. And we're going to solve them by subtracting 7, both sides. X is greater than negative 4. Subtract 7, x is less than negative 10. So these are your disjunctions, so they always have the word or. If you're not sure if it's a conjunction or disjunction, just visualize what your graph is going to be. It's greater than negative 4, less than negative 10. So you're talking about negative 4, negative 10, greater than is this way, less than is this way. So it's creating that disjunction of the two values. Because these are all similar to the conjunction ones, I am just going to fill these out. You can take the time and fill out 9, 10, and 11. We're not really going to talk about the word problem for this one. We're not going to worry about that just yet. So I'll fill out 9, 10, and 11, and you can check your work for it. Please remember for number 10 and number 11 to make sure that you simplify the absolute value inequalities first before you start to talk about the two different cases. So you can see the different values for numbers 9, 10, and 11.